Okay, let's take a look.
It said round to the 100th place, and so it was just like, that was it. It was like a decimal, and then you round to, it was 4 numbers, a decimal, and you round to the 100th place.
Okay.
B partially?
So, yeah, let me...
I didn't have to...
Yeah, in fact, I should have done... yeah, so which one of those is the correct graph? Does anybody know already which one of those on the graphing calculator is the right graph?
A.
Is it A? All right, so let me go back and answer that. 100. All right, so let's take a look. So, so how do we go about doing that? Basically, what is the P? The P is the percent of moisture, and they're saying 50% snow, where P is the percent of moisture as snow. Yeah, let me be more clear. Yeah, so P is the percent of moisture that's snow. So this is some kind of formula. Some is snow, some is, some of our moisture comes from snow, some comes from other things. So P is the percent moisture. So you want basically P to be 50. So you just take in this little formula, and you're plugging in P is 50, right? So 50 equals 83.9 natural log H minus 660. So then you got to solve for H, right? The altitude, the height. So add the 660. And that'd be what? 710. 83.9 natural log H divided by the 83.9. Now, I'd probably just leave that. I mean, I guess you could get a decimal right now. Yeah, I don't know. Maybe you could. All right, I'll do that. So 7 was going to be 710 divided by 83.9. I'm getting 8.46. Use a lot of accuracy because I'm not done with the problem yet, right? 55,304. I'll use all that stuff. Equals natural log H. We get to that point? Is all making sense to here? Now what do we do? Yeah, we've got to lose the log, huh? So in order to solve for H, we've got to lose that log. Everybody with me? So how do we lose that log? Good job. What I see a fair number of times is I see this. So let me address it so I can be helpful to you. I see people divide by the natural log on both sides. That's not right. Right? Because this is not natural log times H. This is not multiplication. Remember, I keep saying it's like a function. It's natural log of H. It's like f of x or something. You couldn't divide by the f, huh? It's not f times x, like a function. That's what natural log is. Natural log or any log is a function. It's like plugged into the toaster, so to speak, right? It's not just multiplied by it. It's plugged in. So you can't just divide off the h, just like you couldn't divide off an f or an x for a function, right? Because it's plugged into the toaster. Well, then, if you can't divide it off, what do you do? If that's not right, what is right? Well, that's where we learned that whole process about losing the log. That's why I did that whole thing. Right, I said when you lose the log, the base stays the base, the other two switch, right? So you want to know that fundamentally for all log problems. When you lose the log, the base stays the base, the other two switch. So what is the base, by the way? E. Is everybody good with that? Remember, we have two, that's supposed to be an E, but it looks funny. We have two understood bases, right? We have 10 if it's just the normal log word, and we have E if it's the natural log, right? The ln natural log said backwards, logarithmic, natural, all French. All right, so that's the base is E. So you lose the log, and when you do, the base stays the base. So he says the base. I'm going to need to move him over because I'm out of room. The base stays the base. The other two swap. So instead of e to the h, it's e to that big long number, 8.462455304 equals, and the h goes over there. So I'll hit it on my calculator now. So, I have the answer there, so I can just go second e to the power and use the answer button. You guys know what I mean by using the answer button? Very convenient, right? Remember, I should show this on the thing here. I got to turn this on. It is on. Okay. Yeah, there we go. Yeah, there's that again. What do? You just turn it off and on? I think so. They freeze a frame or something like that. That looked interesting, though. But let's try this again. See if I can get my thing up there. And then how do you turn this on? Yeah. There. Yeah, good. All right. And then there's a wheel here. Yeah. Okay. So today is graphing calculator day, right? All right, so yeah, so everybody see what I did? So I just divided on the graphing calculator. The last thing they told me to do 710 divided by 83.9. I got that answer. But then instead of writing that down and typing that in, then I just go e to the power and I just do the answer key. You guys know where the answer key is? It's really convenient to use on these graphing calculators. Let me show you. It's down at the bottom. Scoot this up a little bit. It's right down here on the negative. Even if you see it, right down there is answer. So it's very convenient. Anytime you want, you can recall the previous answer, the answer of the last line. So I just hit, I hit e to the power, this e to the power button here. And then I hit second, the negative, which is answer, your previous answer. So it grabs the whole thing. And boom. So I'm getting 4733. So let's write that down. So
you're not going to have that palm on this one.
4733. What's that?
So you're not going to have that rounding palm on this one. Like, for instance, on mine, I still have the answer in the calculator. It had it as 5349. So the 9 would have pushed the 4 to 5, which then it should have the answer been 5400, but the answer was actually 5300.
But it was round to the 100.
Okay, so we're supposed to, let me finish it up first. We're supposed to round to the 100.
Yeah.
So what digit is in the 100? Ones, tens, hundreds. So basically they're saying 4733 is close to what 100? 4700. Does that make sense? That's the answer they want, 4700? On that, no, we're doing altitude, about 4700 feet. We're saying what 100 is it closest to. Remember, whenever you round, you find the place they're talking about, the hundreds place in this case, and then you look 1 to the right. If the 1 to the right is 5 or more, you go up. If it's less, you keep it. And then if you have to go to the decimal, it's zeros the rest of the way to the decimal, 4700. So what were you saying it did?
No, all right. So the answer that I got was 5349. So the 9 should have rounded the.
Okay, back up for me one step. What were the numbers you had before that?
5349.
So no, just like.
So that would have been my intermediate.
So back up to here for me. What'd you have?
E raised to 50 plus 690 divided by 86.2.
Okay, tell me about this. What'd you have there? Like did it give you different numbers?
Yeah, I had different numbers. So that's what I was saying is that this one doesn't have that issue, but on this one, because I had the correct answer, I just had to not round it.
It's actually for us. Oops. Okay, so convert to Fahrenheit. So we have.
You haven't converted the screen yet.
F equals. Oh, laptop. Yeah. Getting lost in my technology here. All right, F equals 9/5 C plus 32. All right, so this is question number 1. We're in section 2.3. Like that. Question number 1, section 2.3. And they're basically just giving us a formula. And they're saying 16 degrees Celsius. So what do we do with the 16 degrees Celsius? Just take that and pop it in, huh? Hit the buttons on your calculator. So the F will be 9/5 times 16 plus 32. And then I don't know from there.
60.8.
What is it?
60.8.
60.8, thank you. Anybody else getting that? Same answer? We have verification? Yeah. All right. 60.8. So that's just a plug-in, and that's all there is to number 1. Let me put it up here for you. Okay, so there it is. This is the form. The last problem they gave us the formula. This one, they're not giving you the formula. They're hiding it. So you can click on the help button. I did the question help, show an example, or you can put it on your 3x5 card, along with everything else in the world, for your test on Tuesday. All right. So they're basically telling me, I covered up the thing now. What was the F? What was it? 102. Thank you. F is 102. That's Fresno in July, right? 102 degrees. So we're supposed to take that F and just plug it in. It's another plug-in. Once you have this formula anyway, it's just another plug-in. So C is 5 times 102 minus 32 over 9, like that. And what is that? Well, I guess you can just hit the buttons. 70. Somebody got that? 5 times 70 over 9. Yeah, 38 point, a bunch of 8s. 38 point, and then I don't know how many 8s do they want. Did they say? Type an integer? I'll go, whatever they say, whatever rounding issue they have. Okay. So let's see. So, whoops. We have, it's the CPI, whatever that is, Consumer Price Index, was 133.3 in 1990, 153.3 in 2000. Notice it says let x equal 0 be 1990. All right, let's hold on there for a minute. So they're saying in 1990 it was 133.3. Do you know what that means? That's a point. That's 0, 133.3. Do you see how I'm coming up with that? How am I coming up with 0? Why am I coming up with 0? Yeah, x is 0 in 1990, they said, huh? That making sense? So I'm doing x, y. How do I know it goes in that order? Well, they made the x be the year, huh? So I'm putting the x first. And then the second part, which is the year 2000, it was 153.3. So what x value is that then?
10.
That's 10, 153.3. Because that's 10 years later than 1990. Does everybody see what I'm doing there? Is that making sense? So basically, they're giving me 2 points, aren't they? By giving me that information, they're giving me 2 points. And you can take those 2 points and you can come up with an equation. You did that in algebra. Remember? I'm sort of kidding when I say remember. I mean, I'm sure you all did it, but you might not. I'm sure it's not something you've done everyday sense. So let's go through how you actually come up with the equation, and then I'll show you on the calculator as well. So you can just do it either way. So let me go to a new screen there, and so we're talking about 0, 133. Okay. So here, let me just put that image down again. All right. So yeah. So again, we have 0, 133.3, and the other one is 10, 153.3. Okay. So what we have to do? This is y equals mx plus b, huh? So we got to come up first off with the slope. Do you remember? Anybody remember how you come up with a slope? The m. Yeah. Remember the y2? Remember that? Yeah, the rise over the run, y2 minus y1 over x2 minus x1. Yeah, so come up with the slope. Yeah, just do the little slope calculation. So let's do that. This is x1, y1. Remember from your algebra days? x2, y2. Like that. So we got to go y2 minus y1. So 153.3 minus y1, 133.3 over x2 minus x1. So you shoot your calculator. Is that 20 over 10? So that's just 2. So the slope is just 2. We got the slope. So that's y equals 2x plus b. Now, how do we get the b? How do we come up with the b? What's that?
So we drop
Yeah, that'd be, yeah. A good observation.
0.6.
I'm sorry, what's that?
Is that? Oh, I'm sorry. Never mind.
Yeah, it should drop out on its own.
Yep.
So the b, yeah, good observation. Yeah, if you remember from your algebra, this is the b, huh? That 133.3. But it's okay if you don't remember all that detail. Just plug in that point, or the other point would work too. This one would be easier. By plug in, I mean plug in 0 for x and the y for the y. Plug the x for the x and the y for the y. So 133.3 equals 2 times 0 plus b. 2 times 0 is gone. And see how b, it does just equal the 133.3. Am I going too quick? Remember that from your algebra days? None of you guys were my algebra students, so I can't pick on you. That's what I usually do. In these higher classes I go, so, Joe, remember algebra 2? And they're thinking, I wish I never had Mr. Heron. All right, so, does that make sense? on that. That's right, Michael, you were. I can pick on you. Okay, yeah. Smart. Yes, that's right. I know she didn't shout out when I said, no, I was. All right, so I won't pick on Michael. So, yeah, does that make sense? Remember that? So first thing I did is I did the y2 minus y1, x2, x1, get the slope. Then, doing the mx plus we got the slope, and then the way you find the b is you can just plug in the point. Boom, and then b is 133.3. So we got the equation. The equation is y equals 2x plus 133.3. That's the mx plus b. This is the m. This is the m. This is the b. We got the equation. So it's this one, huh? It's b there. Is that good there? Questions I can answer on that one, and then we'll do it with calculator. Is that all good? All right, so if you got that copied down, I'm going to go to the next screen and do it with calculator. And what I'll do, I think, is I'll just write out the instructions, and then I'll actually do it with the calculator. I'm going to send you a YouTube as well that I've just found online while I was eating my lunch right before class. A real good one where the guy just walks through the steps. So it's totally, there's great stuff on you. I'm like into this whole YouTube now. I mean, I'm trying to, my sink broke, you know, so I'm YouTubing how to fix the sink, although I'm stuck. There's one little bolt I can't get off. I'm no good mechanically. I'm all theory. So it looks all easy on the YouTube. Just whip this bolt out, and then there's this bolt that's stuck. Anyway, enough with my life story, my problems. So I'm just going to write out the instructions for you, and I'll send to I'll send to whatever email you put into Math Excel right after class. Whatever email you entered in the Math Excel system, I'll just send to the whole class a link to that YouTube as well. He says it better and more clearly than me, and he shows the actual steps on the calculator and everything. It's really nice. All right, so here we go. First thing you have to do, if you guys, now, does anybody have a Casio? Does anybody have a Casio calculator, graphing calculator? We're all TIers then? So I thought I asked you before and everybody was TI. So I mean, I could find a Casio link too, but I won't bother if nobody's got a Casio. All right, so we all got TIs. All right, I'll just send the TI. Except for the 89 folks. I don't know. We can try. Nobody else has an 89? Is that you have an 89? Yeah. So you're figuring everything out okay?
Yeah.
89's tough. It's like a little computer.
No, it's the same thing.
Yeah. Certain you can find it. It can do all this and more. It's more powerful.
If you have an issue, find something you just YouTube on the side.
Yeah. Right. YouTube has good stuff on it. Right. So I was going to send a TI-84 link. I'll see if I can find an 89 one as well. All right. Anyway, here we go. So this is for the TI-84. I'm sure it's very similar on the 89. Or the 83 is the same as the 84, 85. Those are all the same, basically. All right. So what do? First thing is you got to make sure, and this is probably already good, but first, like a one-time fix you have to do to make sure. Can you hit second and catalog? That's at the bottom. Second and catalog. And then you'll get a big list on the screen. And then go all the way down the list to D. Find the Ds. It's alphabetical. A, B, C, D. Find the D. And hit diagnostics. Can I spell this? Diagnostics. On. You want diagnostics on. And then hit enter and enter. Because twice. Once puts it on the main screen, the next time executes it, makes it happen. So you got to first put the diagnostics on. Is that good? So probably it was already fine. Second thing is you've got to go clear your memory banks. So go second, memory. Where's the memory key? Oh, lower right-hand corner. So it's the plus. It's above the plus key. You got the second memory. And you got to hit clear all lists. That's the option you want there. Again, enter, enter. Twice. Once to put it on the main screen, once to put it into action. Execute it. That just clears out the list so there's nothing in there. So we're like ready to go now. We got a blank slate. We're ready to go. The calculator's in the right mode and the lists are clear. All right. So now, here's how you actually do the problem. You go stat. So hit the stat key. which is, where is that? It's in the second row. It's near the top, right below delete. Right below delete. Second row, third over. Down 2 over 3. Right below delete. Hit the stat button. You go into stat mode, and then hit choose calc. So you'll have a menu that opens up, right? Oh wait, I don't want to choose calc. What am I doing? Choose edit. Sorry, we're not to calc yet. Edit. You're automatically on the edit menu, aren't you? When you just hit stat, you're already on there. But you can go across with your arrow and you go into the other menus. We'll go into calculate in a minute. But right now, just leave yourself on the edit mode. So it's just like using a word processor or Excel or something. You know, you go in there, you enter the data, then you go back out, and you go back in and tell it to calculate that data you just entered. That's basically the big idea. It's going to store whatever data we enter, and then we're going to leave it and go back in and tell it to calculate on that data we just entered. That's basically the deal. So we're in edit mode right now. We're editing, we're entering data. And then just go ahead and enter underneath L1 and L2. They're like your X and your Y. Enter our numbers. What were our numbers? It was 0, 133.3, those XY points, you know, and then 10, 153.3, right? So that's like your XY, XY. Enter in L1 and L2, list 1 and list 2. They're like your X and your Y. So put that in. When you're all done with that, just hit second quit. In other words, quit that menu. Quit is in the very top. It's the mode key. That's just to quit whatever menu you're in. It's the mode key at the top. Hit second quit. Come back out of that. And then we're ready to calculate. Now that the information's entered, it's got it stored in its memory banks. Hit stat again. We're going to go back into the stat menu. This time go across to the calculate menu and go down to linear regression. I think it has an AX plus B or something, right? Linear regression, AX plus B. Hit enter, maybe twice. Enter once or enter twice, I don't know. Whatever it takes. And you should have some answers. In fact, you should have, are you guys getting 2x plus 133.3? Want me to try it? Yeah, did yours come up? Let me see. This is Roberto, our class tutor. He loves me to point him out. There's his hours. He's there to help you guys. Our test is Tuesday. You asked me, yeah, right. Yeah, great. Yeah, I'll write out how it looks. Yeah. Yeah. So what you see on the screen is the right thing. It's going to show on the screen. It's going to show y equals ax plus b, and it's telling me the a is 2, the b is 133.3, the r squared is 1, and the r is 1. We'll talk about the r stuff in a minute. You guys getting that on the screen? That's the same equation we just came up with, huh? Right? See, the a is right here. That's 2x plus 133.3. That's the ax plus b. Is that good on that? Does that make sense? Questions I can answer with that? Are those who have the calculator able to get that okay? 89 people? Is anything working? Haven't found it yet? Questions? Shall we move on? All right. That. Okay. So part B, the second question says, in 1992, what's the CPI? So they want me to use that equation that we just came up with by hand and by calculator. Use that equation. And what should I do for 1992? So the first part was finding the equation. The next two questions will be using the equation. Is the right? The 1992 is going to lead us to an x that we plug in, huh? And we subtract 1990 because x equals 0 is 1990. So that means x is 2, because that's 2 years after 1990. So they want me just to plug in x is 2 right there. You guys get what I'm saying? The y is really the CPI, isn't it? consumer price index. The y is the function. It's the consumer price index. And the x is the year after 1990. Does that make sense? See how the x and the y are operating to answer these questions? Right? The x is the years after 1990. The y is the consumer price index. So we plug those in. We're going to get 4 plus 133.3. Is that 137.3? And that's the answer. That's the consumer. That. See what we've done, guys and gals, is we've made an equation for the line that predicts how CPI is going to grow. Consumer price index is going to grow through the years, and so we can use that, assuming that relationship continues as it has in the past. Then we can predict the future based on if it continues to grow in the same way. We can, that linear model. That's called modeling in the math science world, right? They have a function that represents the reality they have seen and assume it continues in the future. You can predict stuff. Is that good? Is that making sense? Questions I can answer? All right. And this is the end of the section. This is the end of the material on the exam Tuesday. So that table, basically put it into your calculator. So you want to go back then and put that thing into your graphing calculator. I won't write all those instructions again, but follow them. You want to basically make the L1 and the L2 become those numbers. So the L1 will be, this will be the L1. This will be, can I just do that? L1, L2. So you're going to make L1, be 150, 185, 210. You got to enter them all. 250, 260, 315, 350, 370, 420, 450.
Do we have to do the diagnostics?
Oh yeah, good question. You don't have to do that other stuff. The diagnostics, you don't even have to clear because this table's bigger, so it'll go beyond the last table. You can clear. You'll need to clear when there's extra stuff in there that you don't want. There won't be extra stuff this time because ours is bigger than the last one. Am I making any sense?
Okay.
Yeah, so you don't need to ever do the diagnostics thing again. You'll never again need to turn diagnostics on. It's automatically on your calculator. So enter this in L1, and then L2 is those other numbers. 5075, 5725, 6,000, 6675, 6850, 7675. It's a lot of typing. You wouldn't want to do this by hand. I wouldn't either. 9875. Yeah, so type all those into L1 and L2. And when you're all done, quit and hit calculate the linear regression line. And what we're doing, if I can, while you type in, if I can just talk, generally what we're doing is there's some kind of a graph here. And there's dots, data dots, like that. And we're finding the best fit line, the line that fits through the middle. That wasn't a very good picture. Let me try again. So that's what our calculator is doing for it. It's called the least squares best fit line, or linear regression line. It has a lot of names. It's called the least squares line, the linear regression line, the best fit line. It goes by all three of those names. But basically, if you could see a picture of the data, if you put this data on what's called a scatter plot, you would see the dots, that we're finding. All these, they all have an X and a Y value. And basically, the line we're finding is the line that goes through the middle the best. That's what we're finding. That MX plus B or AX plus B. It doesn't matter if they call it AX plus B. That's the same as MX plus B, right? It doesn't matter. That's just the best fit line. Also called the least squares line or the linear regression line. So this is how things work a lot of times in real life. They have real life data. It's not perfectly linear, but they go, hey, it looks kind of linear. What's the line that fits? But you have computers, calculators, things like that, fit a line through the data, the best fit line. And the calculator comes up with it for you. So, what do we got, guys? What is the A? Anybody got it? What do you got, Roberto?
15.94, I guess.
What do they want? Oh, whole number, huh?
Just 16.
So we'll round to 16, thank you. And what's the B? 2700? Yeah, it says nearest whole number. Yeah, so A is 16. I'm being kind of scribbly there. A is 16, B is 2700. You guys getting that okay? Put a 16 in here and a 2700 in there. Is that good so far? Should we pause for a second?
Can I have a question?
Like, I found the options for
Okay.
but I don't.
So how many BTUs for 250 cubic feet? So what do I do on this to answer this part B here? So now, see, remember, once you find the equation on step 1, for all these linear, find the line equation things, this mx plus b things, part 1 is always to find the equation, and then once you've got the equation, the rest of them will use it. So they're telling me 250. Is that x or is that y? How do you know? Look up at your original table. It's always x first, then y. What was x? Square feet. This is square feet, so this is x. So plug in x, right? 16 times 250 plus 27. So just always look up at your table. The first is x, the second is y. So whatever that, what is it? Somebody got a number there? 6,700. Thank you. Okay, so there we go. Yeah, so see how they're saying find the least squares regression line. So whenever they say that, you go, oh yeah, calculator. So hit second, memory, and then clear list, right? Clear all list, is that what it is?
Yeah.
Clear all lists. Or whatever yours says. Second memory, clear all lists. So do that and then enter. This will be your L1 data. Notice they say, they always do time kind of, you got to watch how they're going to do time. They're saying X is 3 is 1993. So they're just using that last, they're starting in 1990. So 3, so I'm looking right here at these data. So 3, 4, 5, 6, and 7 is L1. L2 is 21,755. 22, 217. 23, 289. 24, 611. 25, 045. Whoops. 25, 045. Is that good? Like that? So enter that in your graphing calculator and ask it to calculate. And so I'm just going to move on to the next part. Is that okay? So it would just be the same thing. Enter that in your graphing calculator and ask it to find the linear regression best fit lines. Anybody already got it? I can type right the answer.
I got A as 897.4.
897.4.
And B as 18896.4.
Anybody else getting that same thing? Good. Well, you got it working now, huh? You want to show, did you get your 89 working?
I'll figure it out.
You guys want to talk? He's got it. You guys want to get together and talk and maybe you're
different than the 89.
maybe the Inspire's like the fanciest of them all, so it might be similar to 89.
My table is grayed out, so that's.
Oh, yeah, I don't know. All right, yeah. So that's what you should get for the least squares best fit line there.
Number 2.
Yeah, I'm going to do 2 and 3 and some of those. All right, here we go. So yeah, let's look at number 2. It gives me a cost function. And then it says, what's average cost? How do you do average of things, guys? Yeah, add them and divide, huh? Average always means divide. And notice it tells you what to divide. Average cost per always means the thing on the bottom, huh? Per item. Well, X is the number of items. So all that is involved in this problem is to go like that. That's it. You see, when you take the cost and you divide it by the number of items, and that's the cost per item. That's all they want you to do. Is just divide it by the X. So now it's cost per item. In other words, average cost, right? That's all that's going on. Okay, number 3 is more tricky than that, though. Number 3, new car was purchased. 3 years later, it's worth that. Assume that the depreciation value is given by a linear equation. What does that mean? That's what we're doing today. Y equals mx plus b. Y equals mx plus b. So let me kind of scribble that one up. Whoop, getting worse there. All right, erase that. So yeah, so number 3 here. So they basically want y equals mx or ax plus b, whatever you want to call it. So really, do you realize if I can just find the 2 points, the something, comma, something, something, comma, something, you can put them into your calculator or you can do it by hand, find the slope, find the b, and you'll have it. Is that making sense?
Okay.
What are the 2 points?
0 and 14.
Yeah, at 0 years old, brand new in other words, when the car was 0 years old, it was worth 14,500. That's the x. The x is the number of years old, and the y is the value of the car. And when the car was 3 years old, 3 years later, it was worth 9,100. That's your x and your y, your x and your y. You can do it by hand or by calculator. They want you to find the equation. The y equals mx plus b.
So if we're doing it on a calculator, we do exactly what we just did, but only entering those 4 points.
That's right. L1, L2. That's all you would do. Yep. L1 would be 0 and 3. L2 would be 14,500 and 9,100. Like that. And then you get some kind of an equation. Now, a lot of the battle, I think, on a math test is recognition, huh? You've done all this homework, but then you get to the exam and you're like, what are they talking about? Especially a bunch of word problems. This class is all a bunch of word problems. You read it and you go, which one is that? Is that this, that, and the other thing? So I want to help you. I've only got 10 more minutes or so. But what you want to help yourself with, that's why you give you practice down. Because you do need to practice the mix-up thing, which they're all mixed up. I won't put them in order, of any kind of order. They're going to be all mixed up. Is certain buzzwords. So this buzzword, linear equation. That's what has to jump off the page for you. Linear equation. You go, oh, line, mx plus b. Oh, yeah, that's that thing we did with the calculator, finding a linear equation. Does that make sense on that? That'd be the tag. I think if you recognize that, you get a 3x5 card, right? You can put anything you want, everything you want. Maybe you can't put everything you want, but you can put everything you can on both sides of a 3x5 card. And you can have that with you during the exam, as well as your graphing calculator. All right, let's try another one. If there's one you see that you really want done, let me know in these minutes. This is meant to be helpful. All right, whoops, I'm erasing things. All right, where are we at? What do we do? Number 4, a lumber yard has a fixed cost a day and variable cost. The company gets $280 per board foot sold. How many board feet must be produced daily to reach the equilibrium point? What? Lumberyard has fixed cost a day and a variable cost $1 per board foot. That's their cost. Oh, okay. Yeah, and then equal. So, okay. When you see equilibrium point, I know we've talked about a lot of things in these 3 weeks. What jumps off the page? There's 4 weeks. There's 4 weeks. Cost equals revenue. Remember, equilibrium means break even. When does a company break even? When outgoing money equals incoming money. When costs equal revenue. That's what you got to recognize. As soon as you see equilibrium, you think, oh, cost equals revenue. Money going out equals money coming in. That's equilibrium. That's break even. And sometimes they call it break even point. Equilibrium or break even, right? Okay, so how do I do cost? Well, up here, see it's saying cost and cost. One of them is fixed. One of them is variable. The variable goes next to the variable, right? So the cost function is, what is that? 7430.40 plus 1x, where x is going to be the number of board feet sold. So this lumber company is selling lumber, and x is the number of board feet. How much they sell in any given day. How many board feet they sell. A board foot, I don't know what that is. It's just how many feet of board, I guess, they sold. So equals, what's the revenue? The company gets, that's revenue, right? 280 per board foot, so times X. Do you see how that is? Do you see why I knew to put an X on this one? Because it's not fixed, right? The 7430, that's fixed cost every day. To pay their employees and pay their rent and pay their air conditioning bill, it costs them over $7,000 to run the shop. Right? That's fixed. It's going to be automatic whether they sell anything. And it costs them $1 per board foot just to buy the raw materials. And they're making $280 per board foot in profit. So how many board feet do they have to sell to break even? Solve for X, in other words. Right? So solve for X, and you'll find out how many board feet they need to sell to break even. So you just subtract 1X from both sides, which is 1.80X. This is 7430.40. Last step in solving for X always is divide by 1.80, and you'll get some kind of answer which I have no idea of. 4128? 4128 is X. They've got to sell 4,128 board feet just to break even. Anything above that, they're going to be making profit. Below that, they're going to lose. Question?
Yeah. How do you know what equation to use on this?
Where to
plug in the answers or the numbers?
Yeah, so when I read equilibrium points, that was the first thing that keyed me in. Equilibrium means cost equals revenue. That's like a break even. So then I thought, okay, what's cost? Well, I noticed the word cost twice. And I went, oh, fixed, 7430, variable, per board foot, 1X. So the per, whatever they say, per, that means it's times that, right? If I said, I'm going to bring cash for everybody on Tuesday, $10 per student. To figure out how much cash, I'd have to multiply 10 by the number of students, right? Per means multiply. That's when you're going to do a per, you got to multiply. So when they say per board foot, it's 1X. So that's the cost, and the revenue is 280 per board foot, so 280X. So then set those equals, solve for X. X is the number of board feet they have to sell to break even. Makes sense? So practice them over and over again. Let's try a question.
Do we have to write down, we can just put X in the answer. We don't have to write per feet.
Oh, I'm not picky about that kind of stuff. I'm just very happy when I see the right answer. I have not needed to learn to be picky. All right, let's see this one. Classify the function linear, quadratic, exponential. I don't know if you guys know that. Do you know when you look at that, whether that thing's linear, quadratic, or exponential? X squared is quadratic. X squared means quadratic. Linear would be like if you had x and y to the first power. Exponential, what's exponential? Yeah, number like to the x in power. So if you have x in power, that's exponential. X and y first power is linear. X squared is quadratic. So those are the different names of things. All right, number 6. The amount of particulate matter left in solution during a filtering process is given by the equation. Boom, where n is the number of filtering steps. Find the amount left for n equals 0 and n equals 5. So that would just be plug in. See how number 6 is just plug into the formula? Have your graphing calculator. Let me go push. Impossible otherwise. So let me make sure you know the right buttons push. So how do you do it? Remember the high goes high and the low goes low? 69.09. Do the higher one high and the 8's supposed to be low. It doesn't. This program I'm using doesn't. Test generator doesn't put things very low. You just hit the buttons on the calculator. The high goes high, the low goes low. And just hit the buttons. Get some answer. Number 10. Where are we at? Number 10. In the Smoky Mountains of Tennessee, the percent of moisture that falls is, that's the one we just did. See, I'm getting these out of the homework, right? These are very, very, it's going to be homework problems. Number 11. Write the expression as a log of a single number, blah, blah, blah. Yeah. How do you take several logs and put them into one? See what that's saying? It's saying express the log of a single number or letters. They want you to make it one log, single log. How do you squeeze all that into one log? Where does this 9 go? To the power, W to the 9th. Remember, Remember that rule? Front power, plus, so that's times z to the fourth. Remember how adding becomes times for one log? Minus over x minus 5. There's the answer. Everybody see what I did there? Remember those properties? Subtraction becomes division, huh? Remember how we learned that? Adding, these guys who go to the top, becomes multiplying. Powers from the front back to the power, from the front back to the power. Like that. That's all you got to do if you know those properties. Practice those properties. Then this one's vice versa. This one says, okay, now you got one log. It's a natural log, but who cares? All the log rules are the same. Makes no difference. Natural log, regular log, same rules. So now they want me to make it several logs. See that? See here they had 3 logs, make it 1. Now it's 1 log, make it 2 or 3 or something. So that's the other way. How do we do that? Well, is that a TZ? FZ? FZ? It's division. So what's division going to become? Subtraction. Z cubed. Like that. Kind of getting in the way of the other one. Like that. And then I think I said powers go to the front or something, did I? So then you just bring the power to the front. Right? Oh, and I don't know if you know. Well, it's fine to leave the root. I'm fine with that. It is a half power which you could bring to the front, but it's all the same thing. Yeah, I think unless I said something otherwise, so whatever I say on the test, if I say no roots, then you gotta, yeah.
It would be like 0.5.
Yeah, because a root is a half power which you could bring to the front, if it makes you. Well, whoops, I'm scribbling all over the thing. We are out of time, so I hope I covered the hardest ones.
If you take away the root, then
So there could be like more rooms that on that one jam.
What's that?
if you move the half power to the front,